Okay, let's finish up example number one. Let's start with C. With A and B, like I said, B, we just constructed the interval. Now we need to interpret it. So if we have the interval down here, and I'm going to extend the page, the interval we found that we believe the population mean, the average amount of all, the average value lost from all homes in that area was between $8,992 and $10,008. We believe the population to mean to be in that interval. Now, how you interpret that? And it's really, like I said, if you go back to this slide right here, you're basically going to go ahead and write this statement, filling in the percent and your interval limits, okay? So, let's just do that. So, we go ahead and say, we are, now again, this was we constructed a 95% confidence interval limit, okay? So we are 95% confident, sorry about my writing, that the values of, excuse me, I'm gonna review that. So we'll do this again. Okay? Made a mistake, that happens sometimes. So we're gonna say we are 95% confident, that didn't change, that the interval from $8,992 to $10,008 contains the true population mean. Now, I don't have a problem if you write true population mean, or you could just write this. You could also, if you didn't want to write that all out, you could just say mu right there. Now, again, we're estimating the population mean, so sometimes when people construct the interval, they'll put X bar here. Well, we already know what X bar is. We already know what our sample mean is. You're estimating the population mean. All right, so make sure you understand that. So again, we are 95% confident that the interval from $8,992 to $10,008 contains the true population mean mu. Now, what does 95% confidence mean? Well, basically what it means is this. If we took, let's say, 100 samples from this population of houses and calculated the average loss of each of those samples and created an interval, for each one of those 100, approximately 95% of those intervals should contain the true population mean. So, does that mean that this one does? Well, we don't know. We don't know what the population, we are hopeful that it does. Matter of fact, we're hoping that this is not approximately 5 of the 100 that doesn't. So we can say that we believe it to be in there. Again, if you want to take more samples, you can, but in essence, what we're basically saying is that we believe with 95% confidence that that interval does contain the population. We believe it if we again take samples of 36 from that population and calculate and construct an interval that we believe approximately 95% of those intervals should contain the population mean. And we think that this one more than likely does. Now lastly, last question. In the local newspaper, it was stated that the typical homeowner lost an average of $10,000 in home value. Does your data contradict this statement? Well, what we want to do is we want to see, does $10,000, because that's what they're basically saying. They're claiming that the mean is $10,000. Well, if we take a look, $10,000 is in our interval. Now, it's pretty close to the upper confidence limit of 10,008, but it's still within the interval. So really, our data does not contradict that. our interval does seem to contain $10,000, so therefore our data really doesn't contradict that. Now, someone would say, well, does it support it? Does it mean that the mean is 10,000? No, it doesn't. It just says that our interval does not say that it isn't. It does not contradict it. It does not support it, say it is, but again, and there's a difference there. There's a difference between saying we believe it, our interval to say, or our data does say that it is 10,000. It doesn't say that. It just says that we have no reason to believe it isn't $10,000. And that'll become more evident when we talk about hypothesis testing. So does our data contradict it? No, it does not contradict it because $10,000 is in our interval. Now, what happens if 10,000 would not have been in our interval? Well, then we could have said, yes, our data does contradict that. But, again, our data doesn't contradict it because 10,000 is in our interval. So I hope you understand that. So next video we'll look at number 2.